and welcome back to trigonometry. We're going to look at the law of sines, which is one of the laws that we use when we're working with a non-right triangle. So again, the first thing you should always do when you're dealing with trigonometry is to say, is this a right triangle? If so, go to SOHCAHTOA. If it's a non-right triangle, we have two laws. The first one we're going to talk about right now, and that's the law of sines. Let me just tell you what the law of sines looks like. So presumably we have some kind of a triangle, and we're going to label it ABC. These are the three angles, and we're going to name the sides that are across from the angles with lowercase letters. So across from angle A is side A, across from angle B is side B, and across from angle C is side C. And we have no little markings to indicate that we have a 90 degrees in any of these angles, so we are safe to assume it is a non-right triangle. And here's what the law of sines tells us. It says that the sine of angle A divided by the length of the side across from it, that ratio is true if you're setting it up with angle B and side B, and if you're setting it up with angle C and side C. So that, in a nutshell, is the law of sines. It's a pretty easy one to remember, and it's a very straightforward one to use. So let me jump right into an example. In this little triangle, what we have is something like this. And I've kept my labeling pretty consistent, ABC. And here's what we know. This is a length of 9. I've given this a length of 11. And angle A, I've given 52 degrees. So what I want to do is figure out the three missing things, or what they call solving for the remaining unknowns. I want to figure out what is angle B, I want to figure out angle C, and I want to figure out side C. Okay? So those are the things that I want to figure out, and I'm going to just put that over here. Need to know angle B, need to know angle C, and I need to know side C. So I'm just going to kind of highlight that on the side. That's what my answer should look like, those three things. Well, let's use the law of sines and start off with two things that I have a complete set of. I have angle A and I have side A. So that ratio is complete. Sine of 52 over 9. Now that's got to equal sine of angle B over 11. Okay, so sine of angle B over 11. Well, I've got 3 out of the 4 things, so I can cross multiply and divide, and what that will do for me is solve for the sine of B. Now be careful, and you'll see that in a moment. So the sine of angle B is going to be 11 times the sine of 52 divided by, so cross multiply, and then divided by 9. And that turns out to be 0.9631. Now you should always work to 3 or 4 decimal places when you're working with trig. In fact, it's even best if you can just keep all of the decimals on your calculator, and that gives you greater accuracy. Now, I want to solve for angle B, not sine of B. So how do I get rid of this sine that's in front of the B? Well, you guessed it. Sine inverse of both sides. So what I'm going to do to get angle B is be going sine inverse of this side here. Well, you run that through your calculator, and if I'm working to 1 decimal place, my answer is 74.4 degrees. And that's the law of sines in action. Okay. Now, let's go on and figure out what is angle C. Well, that one's really easy to do. Don't need to get fancy on this, because the angles in a triangle have to add up to 180. So to get angle C, all I have to do is go 180 minus 52 minus 74.4 And that turns out when we do that, we get 53.6 degrees. Okay, well that one was pretty much a gift. Not much there. To get the remaining side, side C, I'm going to go back to the law of sines. And I'm going to use the same ratio with angle A and side A that I started with. So I'm going to set that up. Sine of 52 degrees over 9 equals the sine of angle C, and angle C is 53.6 degrees over my unknown, which is side C. Well, I cross multiply and divide, so I'm going to go bottom times top, and then divide by the sine of 52. So here's what I'm doing on my calculator. 9 times the sine of 53.6 degrees divided by sine of 52 degrees. And it turns out if I do that, I get 9.2. And there you have it, the law of sines working for you. We'll catch you later.